Today we'll be doing experiment number 6. Again, another technique for separation of components in a particular material, that is them. And this particular technique is very much used, and you can explore it in your house by using your paper towel and finding the components of your ink pen or your highlighter, etc. And so it's really a fun experiment to do. Now, in this particular experiment, what students will perform is you have a solvent and you have a chromatograph paper. Chroma means color, and it's a sheet of paper or a small block, and which is plated with a compound like silicon dioxide or titanium dioxide. It's just it's spread on it, and then you mark the spots at the bottom. And then you put it in a solvent, and as the solvent moves, the various components move at a different rate, and so they are separated. Finding the height of the solvent which has risen, and then comparing the heights of the other components, we can find out what we call as the RF factor. And the RF factor gives you an idea as to how much attraction is there between the solvent and which is considered as the mobile phase because it moves, and the non-mobile phase. And so with that, I'm going to share my screen with you, and we'll perform it together. So we go and share. And so we go to the file again, open up a new file, and we say partition. We call it 1, 2, 3. Paper chromatography lab. And so, this technology is very much used when we are doing research. And you can see, go through the introduction, and you will see that it's a system that consists of components, a solute, and a mobile phase solvent, and a stationary phase. That is there. So in this particular experiment, till now we have had almost all phases, solvent phases are mobile, because in distillation and things like mixture, salt extraction, fractional crystallization, etc., they are stable and the mixture can be separated. And so now we have 2 phases over here, the mobile phase, which is the solvent that moves, and the base, and the stationary phase that does not move. In paper chromatography, the stationary phase is the filter paper because it doesn't move, and the mobile phase is the solvent that travels through the stationary phase by capillary action. So that's another a technique. So you're using capillary action to push the solvents solute up and down. So the technique is based on by the differential movement of individual solutes through a porous medium, the paper, under the influence of a moving solvent. The RF value, that is the ratio of the difference, may be defined as the ratio of the distance traveled by the substance to the distance traveled by the solvent. And that's what I said. The solvent is right on the top, and then the phases, you just measure the distances and compare it. The migration of the solvent distance of solvent measured from the point of application. If RF value of a solute is 0, the solute remains in the stationary phase and thus becomes immobile. If the RF value is 1, then the solute has no affinity for the stationary phase and travels with the solvent front. So these are the extreme values. 1, no affinity for the stationary phase, and therefore it moves with the solvent. 2, great affinity for the stationary phase, and so it doesn't move. And so we can find out what is the distance between the solvent phase and the experiment that is there. And once you do that, you are given some unknown mixtures, and which may be a combination of different solutes, and you have to find the RF value for the stationary phases, the unknown solutes. And the solutes placed on the paper are dyes, including blue dye B1, green G3, red R3, red 40 R4, 40, yellow 55, and 2 unknown dyes known as unknown 1 and unknown 2. The unknowns are also a combination of the other known dyes. So here we go to the procedure. Add a paper chromatography setup from the equipment menu. So go to the paper chromatography, and there you have it. Then mark the paper with a pencil. And so you can see it is marked at the bottom. Then again go place the solute on the paper, and there you have the solutes are placed, as you can see. So you are basically clicking. Now this in the simulation module, it is very simple, but in real life, you have to sit down and first do one color, then go 1, 1, 1 with the different colors and repeat it so that there is a concentrated amount of solute over there. And then add the solvent into the tank. Then immerse the paper in the tank. And then now you can see as you immerse it, the solvent phases are moving up. The solute phases are moving at different levels. You have the blue 1, green, yellow, red, and then the unknown samples are there. You can see that the red is like almost sitting on the stationary phase, very little movement, where the others are moving fast. And so once the solvent phase is stationary, then you remove the paper from the tank using the procedure menu for paper chromatography and record the distances. So watch it carefully. Once it's done, you go to the procedures for the paper chromatography procedure. Remove the paper from the tank, and now you can read the procedure. Read the positions of each of the solutes, and the solvent line is at 6, then you have 5. So you have 1, 2, 3, 4, 5, 6, and then you can calculate the RF value. And so fill up all of these, complete the answers, and then they ask you what is the composition of the dye for U1 and U2. And so you can write over there. And with that, this particular experiment is over. Just the same thing, take the picture, put it inside. You can copy the whole thing, place it in your lab report, answer the homework, and then complete the lab with the result discussion as usual.